Hi guys, so today we're going to look at something called reference angles. And reference angles are kind of the last key that we need in order to do something called exact values that we're going to look at next week. So in order for something to be a reference angle, these three things have to be true. It has to be an acute angle, or 90 degrees, and it has to be made with the terminal side of an angle and the x-axis. And that's the biggest part right there, is the x-axis. It has to be with the horizontal line, and that's the really important part. And the last thing is that it has to be a positive angle. So this very first one here, we're going to start off pretty simple, a 50-degree angle. So if I want to find the reference angle for a 50-degree angle, I'm going to start by drawing that 50-degree angle. And I know 50 degrees is going to be in the first quadrant. So that would be my 50-degree angle. Well, then I need to see if that fits all three criteria. It is acute, it is made with the terminal side of the angle, which is this line, and the x-axis, so that part's true, and it's positive. So for this case, my actual reference angle is my original angle. No work required. Now let's look at another one. It's not going to be quite as easy. If I have a 130-degree angle, so the first thing I'm going to do is I'm going to draw that 130-degree angle. And I know that's going to fall in the second quadrant. So that is my 130-degree angle. The problem is that's not an acute angle. So the reference angle is what I'm going to find that makes up that terminal side and the x-axis. So between those two places, that distance, that's my reference angle. So I need to know how many degrees there are in that area. Well, I know it's 180 all the way down to that line, and I know that it's 130 up until that point. That in between section, all I have to do is subtract, and I get my reference angle, which is 50 degrees. So the reference angle is what's made up with the terminal side and the x-axis. So we're going to look at a couple more, but we're going to look at these ones in a couple of these in radians. Okay? And the hardest thing again about the radians is figuring out where to graph it. So the first thing I'm going to do is figure out what quadrant 5 pi over 4 is going to fall in. So if you remember, this line is 1 pi. This line is 0 or 2 pi. And if I get a common denominator, 1 pi is the same as 4 pi over 4, and 2 pi is the same as 8 pi over 4. So if I start at 0 and I go around, 5 pi over 4 is going to stop in this third quadrant here. But that's not going to be an acute angle. So the angle I need to find for my reference is going to be with the x-axis and the terminal side. So this section in here is my reference. And if it was 5 pi over 4 all the way to that line, and it's 4 pi over 4 to where the x-axis is, then all I have to do is subtract to get my reference angle, which is going to be pi over 4. Alright, for this next one, we're going to graph the angle 13 pi over 8. So the first thing I need to do, again, I'm going to find 1 pi. I'm going to write it with a common denominator, so that's 8 pi over 8. Then all the way around my full circle would be 16 pi over 8. That's the same thing as 2 pi. So I need to figure out, is 13 pi over 8 going to be in the third quadrant or the fourth? Is it closer to 8 or closer to 16? And it's closer to 16, so I'm in the fourth quadrant. So that's 13 pi over 8, which means my reference angle is the in-between section. And to find that, I just got to subtract. 16 pi over 8 minus 13 pi over 8. And I get a reference angle of 3 pi over 8. Alright, now I got another one. This one's going to be in degrees. So I'm going to graph negative 30 degrees. That's going to go in the fourth quadrant, and my arrow would technically go that way. But with this one, the only problem with this one, I need to find a reference angle that's acute. This distance is acute, and it is made with the x-axis. The only problem is I can't have a negative reference angle. So this is actually just regular old 30 degrees, and that's a really ugly 3. I'm going to rewrite it. 30 degrees. Finally, the last one I'm going to do is 11 pi over 4. So I'm going to, again, figure out which quadrant that's in. So if I went to 1 pi, that would be 4 pi over 4. And if I went all the way around to 2 pi, that would be 8 pi over 4. And you guys can see that one of the first things we're going to have to do here is find a coterminal angle, because 11 pi over 4 is more than two full circle, or more than, not two full circles, it's more than one full circle, which is 2 pi. So I need to take 11 pi over 4, and I need to find a coterminal angle that falls within 0 and 2 pi. And I am doing that by subtracting 2 with that common denominator. So I'm actually graphing 3 pi over 4. 3 pi over 4 is going to fall in the second quadrant, so that's 3 pi over 4. And then the last thing I need to do is just figure out how much my reference is, which is this section right here. So to do that, I've got 4 pi over 4 minus 3 pi over 4, which gives me 1 pi over 4 as a difference. And that's all there is for reference angles. Again, we're going to use these a little bit more next week to combine with some other things to find something called exact values. And that's going to be a really important one that you guys are going to want to pay attention to, because we're going to use that a lot this year.